Recording. Great. Well, for those just arriving right now, we're gonna give it a few minutes for everybody to show up, and we'll get kicked off a few minutes after the hour. Thanks for sticking around. Get a little background music with that. Okay, for everybody just arriving, we're gonna be waiting a couple more minutes for those who are lagging to get on, and then we'll kick things off. All right. Thanks for everybody arriving. As a reminder, just a minute or two, we'll get kicked off. Just waiting for the last arrivals. Yes, and feel free to use the chat. So already got a bunch of people in chat. That's great. Oh, I love everybody sending locations. This is cool. We've got a truly global audience here. It's great. All right, we'll give it one more minute and then we'll get kicked off. I still see a few more people arriving. I'll add my own location. Ooh, got a lot of US, maybe a few outside the US too. Sweet. All right. Last few people arriving. We'll get kicked off in just a bit. Okay, well, let's go ahead and get started. Sweet. Okay, hello everyone and welcome. On behalf of the AI Collective, I am thrilled to have you all here today for today's session on secure inference at scale, real-world AI deployment. This event is brought to you by us, the AI Collective, and Protopia AI, and it's part of our commitment to bringing our community the most cutting-edge insights from the frontier of AI. So, if this is your first AI Collective event, know that we are pioneers in the frontier, right? This technology, AI, is evolving every single week. It is incredible how fast things are moving, right? I like to think of us here, human progress through time. We are right at the elbow of the curve with things moving so fast. And you on this call, anybody who's part of this community, we are the pioneers of the frontier, exploring what's coming out week by week. And this is certainly an example of that. The AI Collective is more succinctly a nonprofit grassroots community uniting 70,000 pioneers exploring the frontier of AI in major tech hubs worldwide. So this is a global movement that started here in San Francisco in 2023 and is really spread all around the world. We have 50 plus chapters. We host many online events, and thank you all for being here for this one. The obligatory showing of logos, where our members are from and who we've been fortunate enough to partner with in the past. And let me get back to our panel. So we have an incredible lineup today that's going to be talking through with me how we protect sensitive data during inference without slowing down innovation. So I'm gonna bring up each panelist, and I'm gonna introduce them in a few words, and then I'll give them about 30 seconds to introduce themselves. So first up, we have Iman from Protopia. So he's the expert in ensuring that no plain text is ever exposed during inference, making sure sensitive data stays private. Iman, do you want to introduce yourself?
Yeah, thanks, Chappie. I'm Iman Ibrahimi, CEO and co-founder at Protopia AI. My background specifically is in systems architecture, and I spent about a decade at NVIDIA, where a big portion of that was working on the system designs for essentially large language models, both on the training and deployment side. It's great to be with the great panelists here and look forward to the conversation.
Love it. Awesome. And next we have Nico from Cyborg. So he's here to talk about how encrypted vector stores can secure that tricky retrieval side of AI without sacrificing performance. Nico?
Thanks, Chappie. I'm Nico Dupont, or Nicholas Dupont, or Nick, depending on when you met me. I'm the CEO and founder of Cyborg, and we're working on, as you mentioned, Chappie, end-to-end encrypted vector search and retrieval for AI applications that really focus on securing big vulnerability in most enterprise AI applications today. So excited to talk about it.
Love it. Okay, next we have John from AWS. So he's going to give us that big picture infrastructure perspective on how secure inference fits into scalable architectures. John?
Hello, everyone. My name is John Liu. I'm a principal product manager at AWS, specifically for the service Bedrock, which is a fully managed model serving platform. My background really stems back to traditional finance, Wall Street finance, for about 9 or 10 years, where I was trading bonds and credit default swaps. And then I went to a variety of startups, including a bunch of Web3 crypto startups. And I joined AWS about 4 years ago to build scalable infrastructure and data services.
Wonderful. Thanks, John. All right. And last but not least, we have Istvan from WWT. So he's our voice of customer and industry experience, showing where real world deployment runs into security gaps and how to bridge them. Istvan?
Yes, hi there. Thank you so much. So I'm the global head of AI security and cyber innovation at WWT. And that goes a lot with, talking to our customers about how they deploy and implement these technologies on their everything from AWS, GCP, physical hardware, etc. Been in the industry for 25 years plus, spent time at AWS as well, loved the Bedrock platform, and excited to be part of the panel.
Amazing. Okay, so to give everybody a little background on this panel discussion before we get into it, we're going to be focusing on the stage of the AI lifecycle where sensitive data is most at risk, is inference. All right. So at this point, live prompts and embeddings flow through our vector stores and LLM pipelines, but where they can leak is through logs, memory, or search queries. So enterprises and AI native builders for regulated industries often discover these gaps late in the build process, which can stall or even entirely derail deployments. So this really is the frontier of AI. Let's get right into it because we got a lot of topics to get to. So first, let's start with top challenges in deploying AI on sensitive data at scale. John, I want to start with you. Just tell us how AWS helps keep sensitive data secure. We'll go from there.
Sure. So for those not familiar, Bedrock launched about 2 years ago, and it's really about bringing the AWS expertise on how to manage infrastructure at scale and keep it secure to help innovation with Gen AI, right? And then we address security from multiple angles. So we'll cover some of the basic ones. Like one of the top concerns from customers were always, at the time, do you share the data even back to the providers? And that was one of the first controls we put in. Like every single one of the models that we host are fully closed in the fact that they don't have any inbound or outbound requests that are not authorized. So think of them as kind of network isolated accounts, and all the only inference requests made by customers are actually sent to the models themselves. So none of the data is ever shared to the provider. And then you have various security postures that you have to put in place, right? You have to make sure that all the calls are encrypted in transit. So all our calls inference requests are secured by TLS 1.2. And then also when the data is encrypted at rest, and the tools that we offer, such as knowledge bases, that information is also encrypted with service KMS keys. Those just secure keys that AWS offers. And some of them can even be encrypted with customer managed KMS keys. So everything's fully managed. You have various points of security. It's encrypted, right? Both in transit and at rest. In addition, for workloads where you actually have private data that's coming through, or a customer has some VPC that they can connect that to Bedrock through AWS private link. So we kind of cover that full traffic. You don't even have to send your inference requests over through the public web. They can exist within your VPC. And the other thing that I like to think about is, we don't just start with inference requests and kind of knowledge bases. There's a lot of talk about agentic workflows these days, right? So we took a lot of the expertise that we had when we were building Bedrock, and we just launched Agent Core in public preview. And one of the primitives that was exposed is something called a secure runtime. And here, think of these as like micro virtual machines that you can deploy, and you can deploy and run your own agents. You can call whichever LLM that you have, and we help scale on the back end for you. So it just removes a lot of the undifferentiated lift from developers while help keeping the data secure.
Love it. Love it. Okay. I want to talk about it a bit from the other side too. So once again, we're talking about deploying sensitive data at scale. Istvan, maybe you can talk about it a bit from the enterprise side and problems from the enterprise side.
Yeah, especially in a global perspective, right? There are different compliance and regulatory requirements all over the world, right? And, what we also find is that customers generally don't only have one LLM provider that they're working with. So being able to not only secure it at that large language model and at your infrastructure layer, but also being able to provide controls across various models and various providers is incredibly important. In addition to that, of course, segmentation and isolation. The challenges with, as you start segmenting and isolating different workloads on different large language models, is that the price immediately goes up, right? Because if you've got to isolate a certain set of data, then generally you'd put a large language model in front of it with a separate vector database, separate backend RAG platform. Now you do that again for the next set of data, becomes really expensive because it takes numerous GPU cores, etc., to be able to drive performance at scale. So also looking at a lot of these technologies, it's creating a better ecosystem of being able to create that segmentation and isolation of the data and the aligning to those regulatory and compliance requirements, while being able to optimize the usage of those large language models in the environment that it is now.
Great. Okay, so let's zoom in a little bit. Still talk about deployment, but let's talk about inference specifically and why inference is such a critical exposure point. So, Nico with you with Cyborg, and then Iman with you with Protopia. This is really what you're focused on. So maybe Nico, we start with you and talk about how inference is that critical exposure point and how you're working with that.
Yeah, absolutely. I mean, it makes sense when you look at it from when you zoom out and look at the entire application lifecycle, right? Inference is the time where you're actually getting that value from the data with your AI models and your AI application. And we're specifically focused on vector embeddings, which are those dense representations, kind of the language of large language models. And there's really two parts to understand why we need to protect, why it's so dangerous when vector embeddings leak, and why they leak in the first place. The first part is it's very common to think, it's a common misconception that vector embeddings are like one-way hash functions, that you take data in its original modality, so text, images, audio, you encode them into vector embeddings using a transformer model, and then you can't get it back. But actually, that's been proven time and time again that you can invert vector embeddings back to original text, images, audio with very high fidelity in a relatively trivial manner. And the second part is that vector databases traditionally leak vector embeddings throughout the application lifecycle, meaningfully or not, because they're relatively immature technologies largely compared to the 50-year-old relational databases that have had the time to mature in the market, but also they operate in a different paradigm than regular standard databases, wherein the vector embeddings need to be held in plain text, at least in memory, in order to be able to do similarity searches. So that's a huge attack vector that hasn't existed before, where you have dense representations of the data that is centralized, unlike a lot of other applications, and that can be fully reconstituted to original data.
Awesome. And so, yeah, Nico, that's one side with the vector stores and embeddings. And then, as I was saying, Iman, you're on the other side with Protopia and maybe more focused on the plain text side. You want to go into that as well? Just describe everything there.
Yeah, just when we think about inference, right? Why inference is such a critical exposure point? I think there's three things that come to mind when we're thinking about inference in particular. First is that inference, unlike training, is almost only going to provide the relevant outcomes for the use cases that people are deploying if real data is used. In training, sometimes you get away with being able to use synthetic data to train a model, and you're not actually exposing any real data. In inference, that's almost never the case. You're trying to make actual outcomes occur. Those outcomes rely on real data being fed to them. Another component is that inference ultimately is where most of the cycles end up being spent with a model. You train a model, you fine tune it, but then when it goes into production, that's where most of the cycles of actually data running through these pipelines occurs. And the usage models that exist around AI inference, whether it be RAG pipelines or now agentic workflows or reasoning models, at no point have we had a setup where we've needed to connect so many various sources of data in the enterprise to applications that we want to run, often on managed compute. So this topic of enterprise data being piped in this continuous form from all corners of the enterprise into servers where we want them to be managed because that's more cost efficient, and we'll talk about that. But ultimately, now you have all sorts of different sources where plain text information can leak. It's not just about an ephemeral moment in time in memory either. So some people will talk about just the in-use component of the life cycle. So John was mentioning at rest, things that are encrypted. In transit, they're encrypted. When they arrive at the server where the computation is going to be happening, they're decrypted and they are living in that decrypted plain text form, both during the computation, but also during events like logging, or if there's a spill that happens from memory to disk. There are more and more reasons why data that exists on the server running the models in the tenancy that is managed by an entity other than the data owner can end up persisting as well. And so that plain text exposure often gets addressed by many different either enterprises or AI native application providers that are building for the enterprise. It gets addressed by what Esteban was bringing up, right? Of make the compute dedicated if the data just cannot appear in plain text somewhere else. But of course, there are costs associated with that, which I'm sure we'll get into.
Yeah, exactly. And you hit it on nail in the head. That's exactly what I want to get into next. So most people, when they're trying to keep their data secure with inference, would just say, "Oh, run things locally," right? So give us a sense of the performance and cost considerations of something like that, isolation versus a managed solution, and how to think about this. Iman, we just go straight back to you.
Yeah. Well, when we think about performance, right, I think for a lot of applications, the topic of performance is around the accuracy and the relevance of the outputs that are created by the model that's being run. And when you think about relevance and accuracy, where does that come from? That comes from the ability to use actual real data that is relevant to the use case. If you're able to use that data, whether it's in the semantic search component that Nico's talking about, where you're trying to actually find the most relevant documents to a question to answer, for instance, you need to be able to access that data. Or whether it's you want to feed that data now to a language model to provide you the answer back, again, you need to be able to use the most relevant data. But there's often friction with, okay, what is the ROI then in terms of relevance is that return, but then the investment associated with the compute necessary to actually come up with the answer. If we go towards dedicated compute all the time for any instance, which is something that happens very frequently. In fact, for a lot of AI native application providers, it's the first answer. We don't want to get into the conversation around privacy with the enterprises that we're selling to, so we will just deploy it however it is that the enterprise wants it deployed. If it's on-prem, if it's in a particular dedicated environment in the cloud, that's what they'll lean towards first. But ultimately, the question then becomes, are there enough inference requests to keep the utilization of the compute that you have dedicated to that data owner high? Because if you can't create enough inference volume, then the utilization of that compute goes down, which then just turns into costs that somebody has to pay. Either the enterprise, if they're deploying it for themselves, which eats into the cost envelope of the use case. And somebody might say, okay, well, that use case doesn't provide the benefit that would make sense. Or in the case of AI native application providers, it'll eat into their margins, which prevents them from being able to scale. So that's part of what we see in that kind of relevance and ROI friction.
And I'd like to just say something. The opposite's also true, right? Iman, the challenge is that if you don't give it enough compute and you limit it, then the scaling aspect becomes 100%. Really tough, because it's not as easy to just, get GPUs at the moment on the open market. You may scope something for a certain amount, but suddenly your application or your platform kicks off and you need to 3 times or 5 times grow that. It's not always that easy, right?
Yeah, absolutely. So actually, just quickly bouncing off of that, some of the especially larger models, right? Some of the larger models require a large number of GPUs to actually be able to run them in a performant way. So when you talk about dozens, if not 100 or more GPUs in the case of some very large models, the most latency efficient way of serving them in order to be able to get an answer for a single request requires using a large number of GPUs. But then the question becomes, how do you keep those GPUs busy? And that's again part of the whole cost and availability and then relevance trade-off that we're talking about.
I think these are very good points, and they're actually the toughest challenges that AWS is looking to solve with Bedrock and its managed services. I mean, you've brought up some very good questions on how do we protect data? And part of what we work with enterprises and startups is making sure they have the option, the ability to encrypt all the data, and whether it's going to be knowledge base, whether it's going to be their logs. As you said, there are some new ways to access data that people, because they're working through LLMs, may not be aware that they need to patch, but we give our customers that support so they don't always have to go with, hey, if I want secure data, I got to deploy on-prem, right?
Absolutely.
That is definitely one path that we have available, but as you pointed out, the ability to scale that and fully utilize the capacity is actually very challenging. So
which is exactly why those enterprises and AI natives would love it. The thing we hear often is, gee, I'd love to be able to use a managed service because it scales so much better. And how do I go about doing that while being able to use the sensitive data is the topic at hand. Yeah, couldn't agree more.
Yeah. Okay, I did want to dig a little bit deeper into that with the infrastructure choices and then how that shapes security and scale and how you think about that. John, I had you on this. Did you want to touch any more on that?
Yeah, we kind of already touched on it a bit, right?
Yeah,
we help with customers as well is address that thorny issue. Like, how do we find the best instance so that we're serving information both quickly and making sure that the answer is also accurate? Because, like any provider out there, if you want to serve an LLM, there's some optimizations people have to do to make sure that it's running very quickly, right? Especially when it comes to some of these open source models that come out there. The actual model providers don't go through and optimize for every single platform. It's not their job to do that. It's our job, right, to make sure customers get it fast. So we spend a lot of time to make sure that we give customers both the accurate and performant responses on inference. And we also make it available globally too. But we try to make it available as many regions as possible.
Yeah, awesome. Okay, so let's move on to timing, because I think this is very important given who our audience is. We have people who are probably working at some of the largest companies in the world. We also have a lot of hackers who are even vibe coding projects. When does it make sense to start thinking about and integrating security into your design? And maybe, Iman, we start with you.
Yeah, I think it's often the case. Let's just first real quick touch up on how people go about it today, right? In many cases, I think when people in the proof of concept, and by that I mean either internal to an organization, large enterprise, they're building the use case out, what it's going to deliver, often they will not necessarily be paying attention to the question of, well, what data can go to what compute in order to be able to deliver this, mostly because they're focused on, is this use case even worthwhile, right? And the same can happen in an AI native application provider that's selling to enterprise, where they show up and the first kind of order of business is just prove that what it is that this application is going to provide is solving some problem for the business, which is great. That is like, without that, what's the point? But the question then very quickly becomes, if you're not paying attention to, well, how will you take the most relevant data and get it to the compute that can run that application? And when we talk about getting it there, we're not talking about the transit layer, because obviously everything that John said already exists, right? You can bring the VPC all the way to where the managed application is. There's no challenge there. But then someone in the organization that owns the data will have to make a decision of what tiers of data are they comfortable showing up in plain text on a managed platform, right? And they often will make that decision independent of anyone that is having that setting up that platform, solely because they're never have had certain tiers of their data appear somewhere else in plain text. And so the decision making becomes something that happens later on when they're trying to go to production. And that step of going from POC to production will often see a lot of this conversation about cost, about ROI of the use case pop up, where cost and ROI of the use case happen to be hand in hand with, can you keep the data private and be able to use some scalable platform like Bedrock and use it for most of your tiers of data without having the data owner say, no, I can't have that use case run on this data in said target. And so having that conversation come a lot earlier in the process, where even during the proof of concept phase, you're able to, either as the person building that use case inside an enterprise or as the AI native application provider, be able to say, I have line of sight into how this will go into production. It's something that we've actually seen our partners at WWT, Esteban and his team, they help enterprises with that all the time. So I don't know, Esteban, if you have some insight you want to add there.
Yeah, absolutely. And if you're talking about when to do this, you know, the security industry generally speaks about the earlier the better, right? The challenge is that a lot of the AI workloads were very research focused over the past couple of years, with a lot of it really going into production in the last year and a half. So in that research space, there's a lot of lax controls, because we want to be able to give researchers, data scientists, and the builders the opportunity to think outside the box, outside of controls, figure things out. But as they're getting to the production environments, enterprise controls need to apply, right? And when you're deploying these out without the controls in place at the front, it actually requires a refactoring of those workloads at a later stage, which not only impacts your return on investment, because now you've got to take things offline potentially to be able to refactor it. You may have to redesign certain application aspects of that. But in addition to that, you know, the security team being brought in potentially later in the process, now they actually have to play catch up, right? So a lot of times we talk about identify the architecture that you're looking at. Make sure you've got the resiliency. Make sure you've got your data protection in place. Make sure that you've got your compute architecture, because it's extremely important when you're expanding to thousands of GPUs. You need to make sure that from a connectivity perspective, that they're all correctly configured, because you may want to buy a certain set of compute, whether it's from AWS, GCP, or NVIDIA directly. Architecture matters, because expanding isn't always easy, because you have to get close locality. Those nodes need to be close to one another to be able to work as a single compute platform. So security is extremely important early stage, tying it back to your governance, risk, and compliance as well.
Love it. And Nico, so I want to give you the opportunity to close out kind of this panel discussion. A lot of content to go off there. Any parting thoughts you have?
Yeah, I mean, I think I agree with everything that John, Iman, and Istvan had to say about this. I think security needs to be brought in very as early as possible in the ideation phase and architecture, because you know, you want to spend you want to make decisions relatively quickly, but decisions that are hard to reverse, like architecture, you want to take your time and really think through them. And I think it's also incumbent on companies that are providing security solutions like Protopia, like Cyborg, to try to make it as painless as possible from a technical architecture and developer experience point of view, to where today, if you want to spin up, a Node.js server and have HTTPS instead of HTTP, so you have TLS 1.2, encryption over your web server, it's super easy, right? As a developer, it's almost like you would have to go out of your way to disable that. And I think that's the ethos with which we've built CyberDB, and we try to approach the problem. How do we make it as easy as possible for developers to make it almost a no-brainer to choose the secure option?
Perfect. All right. Well, I think that's a great segue. I want to move on to our next section here. So I'm going to bring up, let's see, Iman and Nico to come talk about or get a little more practical with a quick live demo. I'm just going to go to the next slide here. Everybody can see my screen, right? Good. Okay, perfect. Well, I'm just going to move on to this next slide and would love to talk through, Protopia AI and Cyborg and how you guys are working on this solution. Walk us through this.
Sure. I'll start talk about the several pieces and hand it off to Iman to talk about the Protopia parts. So here we have a grossly oversimplified view of a common paradigm in enterprise AI, which is RAG, retrieval augmented generation. In here, you've got really two main parts. You've got the data owner root of trust on the left, which can be defined by the data owner's threat model. It can be on-prem, it can be in their VPC on AWS, it can be in trusted execution environments, confidential computing. That's defined by the data owner. And then on the right, you've got the LLM endpoint, the runtime where the large language model is operating, which can be internal or external, which is really an important thing to highlight in this architecture. Starting inside the data owner root of trust, we have an embedding model that is used to be able to embed documents that get ingested as well as queries. So convert them, encode them into vector embeddings that, as I mentioned earlier, are dense representations of the data that encapsulate semantics. And those are then fed to CyborgDB, which is our contribution to this architecture. CyborgDB is an end-to-end encrypted vector database proxy. So what that means is it integrates with key management services and commodity backing stores like Postgres, Redis, AWS RDS, for instance, and takes in vector embeddings, IDs, metadata, and original data, encrypts them, and creates an encrypted index to where then we can do similarity search on that encrypted data without needing to decrypt it. And so that's what we see in this pipeline, where a query is also embedded and then fed to CyberDB to do the semantic search and retrieve back just the top K results that can be decrypted and then fed to alongside a system prompt and the original query as context to the LLM, or in this case, to actually Protopia's stained glass transform. Iman can tell you more about.
Yeah, the stained glass transform in this architecture diagram, you can think of it as there's a proxy there that mimics how the data owner would have interacted with a language model that didn't have stained glass in front of it. So the input side of the stained glass transform will, for instance, be an OpenAI API compatible input, where you are speaking to the stained glass transform on the left-hand side with the plain text of those documents that Nico just described would be searched and retrieved. And then the stained glass transform transforms those in a stochastic manner to embeddings that can be consumed by unmodified target foundation models. So these transformations are foundation model specific. They're not one single transform for any given foundation model. They are trained to be able to create stochastic embeddings that are specifically understandable by that target model. And these stochastic embeddings, we use the word stochastic just to differentiate from deterministic embeddings that you would get back from just invoking an embedding model. These stochastic embeddings will look different every time for the same set of tokens on the input side, which is really the part where there's IP involved here of how do you come up with a transformation function to be able to map what is deterministic tokens to a set of stochastic vectors that are understandable by an unmodified foundation model. But then the model creates an encrypted response that is only understandable in plain text within the data owner root of trust. And we'll walk through some of this in a live demo here right after this, I believe. So I'll keep
Sweet, yeah. Let's do it. Okay, I'm just going to reshare my screen so I can support video because I know our walkthrough is a video here. Optimize for video. Okay. And hopefully everybody can see my screen again. All good?
Yep.
Sweet. Let me just go move on to that next slide and you can walk us through this.
All right, awesome. So this is a demo of a RAG application using Cyborg DB and Protopia AI. We start off by adding in a file to be ingested. When we click this Create Vector Store button, it actually invokes the embedding model and chunks the file, creates embeddings for it, and then ingests it in Cyborg DB. As we can see here, there's 100 chunks in that file, it's chunked into 100 pieces, and we see previews of the ciphertext for the first 10 chunks. Those are encrypted using symmetric encryption, and those will remain encrypted throughout the application lifecycle so that the vector embeddings cannot be leaked, or if they are leaked, they're encrypted themselves. And then when we do a query, we can type in a prompt. That prompt will be embedded using that same embedding model, fed to Cyborg DB as a query embedding, and then we can find the top K, in this case, top 3 most relevant chunks out of those 100 chunks, and then only decrypt those to be fed to Protopia stained glass transform.
Yeah, and so when the transform happens and we go to those stochastic embeddings that we just talked about, what is appearing at that LLM endpoint, if it were to be observed as plain text, looks like that box on the bottom left. So I actually see a question in the chat about what happens to mask confidential data. We're not masking confidential data by replacing it. We are transforming the entirety of the prompt into a representation that is irreversible, as you can see by the attempted reconstruction at the bottom here, to the original. But the information content can still be used to come up with an answer. So you can combine this with tokenization solutions, of which there are many, if you are trying to tokenize or mask something before sending, but then we are transforming the entirety of the prompt, including any context. So these files, these chunks that, for instance, were retrieved alongside the prompt itself will be transformed in their entirety such that the information will not be something that can leak in plain text. And if somebody were to either grab something from memory or from logs or any sort of unauthorized access on the LLM endpoint, the bottom left is what they would be able to reconstruct to, which comes from trying to, for instance, do nearest neighbor search or any sort of reconstruction that involves searching what embedding to go back to. We spread the kind of randomized version of the embeddings across a large space, and that's why the reconstruction of the text will look like that. And so just going through a couple of these examples, you'll note that the responses that come back from the model will still be understandable to this chat session, but they are only understandable to this chat session. So the responses are created in plain text, but they're only viewable by the data owner that holds a private key within that data owner root of trust. So I'll pause there, and Nico, if you want to add anything else at the end of this.
Yeah, I mean, you highlighted everything that's relevant, but as you can see, the functionality of this RAG pipeline, of this RAG application, is unchanged to the end user. The APIs, like Iman and I have mentioned, are also unchanged. It's a very standard vector database and OpenAI LLM compatible API endpoints, and performance is within the same performance envelope. So we really work to build this to be an end-to-end solution that guarantees security and privacy throughout without changing the developer and end user experience.
And just to add one last thing here, we talked about having this be simple to use. We also spend a lot of time, I think we certainly do at Protopia and definitely at what we've seen at Cyborg as well, to fit into what it is that customers want to use or are using today. So things like AWS Bedrock, which are really important in terms of being able to use a managed scalable service, is something that we have recently been working with the AWS team to enable endpoints within, for instance, SageMaker Marketplace that you can launch and have stained glass sit on the data owner root of trust and be able to speak through that stained glass to an endpoint within AWS. So that's part of us fitting into the workflows that already exist, so that complete re-architecting of how the inference pipeline looks like is not at all necessary. You're basically sliding in a data privacy layer, which can live as close as possible to the boundary of that data owner root of trust, which, as Nico was describing, can be on-prem, it can be within the VPC, it can extend into AWS itself. But now you get the protection of no plain text outside of that data owner root of trust.
Yeah, I love that, by the way. It's just like how you're wrapping in additional layers of security on top of layers of security, right? And as you mentioned, these are, by integrating with SageMaker or Bedrock, these are existing workflows. It's almost an endpoint that an enterprise customer is going to hit. So they've got the same type of security protections they would if they were just accessing any other Bedrock model or SageMaker model that we have. And now you have this additional encryption that sits even up for data.
Perfect. Well, that was a super helpful architecture walkthrough and live demo. I also see that in the chat, Brittany's added a link for a deeper dive into the architecture, because clearly there's a lot going on there. So if you want to explore that, by all means. Let's go ahead and take this moment to move on to take a few questions from the AI Collective community. So if you would like to get involved, if you'd like to ask any questions to the panelists, now is your time. Please go ahead and drop them in the chat. I see we already have some questions. Now, panelists, of course, you have access to the chat as well. Feel free to just jump in and take any of the questions you'd like. Otherwise, I can also kick us off. Anybody want to get us started?
Yeah, I just see one here that Gio asks, any recommendations for deploying AI infra in air-gapped environments? Just from the perspective of Protopia, and I'm sure the other panelists will have some color for this as well. From our perspective, Protopia stained glass is delivered, the stained glass proxy that we talked about that does the transformation is delivered as a Kubernetes container that can really be deployed wherever you have some minimal amount of compute. This means that we are removing the need that traditionally, again, if you wanted to run, say, a language model on your private data, you would have to figure out, well, do I have the GPUs to run this right next to where the model is? Instead of having to figure out whether you have a few, sometimes dozen, sometimes more GPUs to be able to actually parallelize the model, we're saying if you even have a high-end CPU next to where your data lives, you can take that Kubernetes container, run it there, transform the data, and then open up to compute that is more accessible and more scalable and more cost efficient in a place like AWS or otherwise. And you are now able to take advantage of essentially what is managed inference without needing to expose the data. So the air-gapped environment, very much you can run the transformations in such an environment, and that can then lead to either an LLM that is hosted within that air-gapped environment outside of the data owner's root of trust, or even move to the cloud as well.
And we're seeing that quite a bit at the enterprise level, especially within healthcare, life sciences, genomics research, etc., where the language models are really designed to serve the research community within the organization, and they essentially air-gap that space just because of the huge amount of IP that's in that environment. And the use case isn't really required outside of their research labs. So being able to deploy Protopia and Cyborg in those environments for the different teams, for instance, is extremely valuable, because instead of having to, split up large compute clusters, now being able to serve that with single LLMs makes a lot of sense, because it improves the performance and day-to-day capabilities of those clusters.
Sweet. Okay, well, we got a lot more great questions coming from the community. I'm sure you all are looking at the chat. Does anybody want to jump on any of these? Otherwise, I can ask one of them. There is one about AWS, John. I don't know if you see that. Can we get an AWS cloud formation template that was used to deploy this architecture? Is there one available?
We don't have one available yet, but I'm sure Protopia, we can come up with one.
There we go.
Yeah, and one of the ones there from Dawn, and Imam, I think you're going to be able to respond this. Is this more a classic ML approach versus a sole deterministic approach? And does it add a lot of heavy lifting to the LLM, or how's Protopia and Cyborg optimizing this for scale?
Yeah, thanks for pointing that out, Esteban. So the transformations that we reference as stained glass, they are neural networks themselves. In fact, they are small transformers, small with respect to the actual LLM that you are targeting. And that's where this difference with the deterministic approach of just creating and embedding for a certain set of tokens comes from, where now you're not just going from tokens to those embeddings, you're going from tokens to something that is randomized, meaning at runtime, you are drawing a certain set of numbers from distributions and then applying those and then getting the answers. So there is some ML involved. In terms of the LLM itself, there's no heavy lifting in that we are not changing the LLM. There is a transform that's being learned a priori to the inference pipeline that we talked about for the target LLM. And with foundation models, for a lot of the popular open ones, like a variety of Llama models or Mistral models or Quinn, many of these transformations have already been trained by our partners, and they exist, and we can package them as part of basically licenses, which is how we deliver this. But I'll keep it at that. We can follow up with more detail.
Great. We got time for probably one or two more. Anybody want to jump in any of these?
Yeah, I'd like to ask a panel. Vinny brings up an important point. I feel like a lot of conversations we're having today with customers is AI or quantum, right? How is quantum and post-quantum timelines going to affect these transformations? Is it similar to standard cryptography where there's huge potential risk? And how does these controls actually survive post-quantum?
I can jump in about the Cyborg component here. So this is all of our cryptography is based on either symmetric or lattice-based cryptography, which, as far as current research is concerned, is considered post-quantum secure. There are some theoretical potential, quantum algorithms that could break it, but the Shor's algorithm, which is the kind of the big bad quantum, like post-quantum algorithm, their algorithm that's meant to be breaking cryptography, is applicable for asymmetric public key encryption, which we don't use. I can let Iman speak to.
Yeah, no, I think if we were to try to get into the quantum part of this conversation, it would be a whole other panel, and there'd be a lot of opinions to add there. I do want to address one of the other things on here, if the panel doesn't mind, that talks about when taking infrastructure and scalability into perspective. David Carter asks, are there instances where GPUs could be complemented with CPU without losing the functionality? Mainly for smaller businesses that may not be able to maintain hundreds or thousands of GPUs. This is actually very, very relevant to why we believe being able to run private compute with services that are fully managed, like a Bedrock or others, is really important, because owning and maintaining hundreds of thousands of GPUs for at-scale inference is just not realistic from a cost perspective for AI native application providers or even small businesses building their own. And so the idea that with CPUs, you can do transformations that are within your four walls or within the data owner root of trust, and then be able to feed GPUs on demand and when you need them with requests that are managed in AWS tenancy, that's an unlock from a cost and delivery of value perspective. So what we are doing is exactly actually for that, if I'm understanding the question correctly, David, but happy to follow up if there's other aspects to that as well.
Great. Well, we're just about to end things off, but any parting words anybody wants to impart, any final wisdom? If not, I'll jump straight to it. All right. Well, This has been awesome. Thank you all so much. On behalf of really the entire AI Collective community, huge thank you to all the panelists, all the speakers, and want to thank everybody who is currently here, pioneers of the frontier of AI, for joining today. I hope you got as much out of this as I did. My key takeaway is you can secure your inference today, right? Encrypt retrievable, eliminate plain text exposure, all without breaking any of the workflows or performance that you already have. If you want to continue the conversation, plenty of ways to do that, right? Go check out our website, go engage with any of the panelists on LinkedIn, and then keep an eye out for our upcoming AI Collective events. We have plenty more coming online, plenty more in person. And I'll jump to this last slide. You can scan this QR code as well. I believe this takes you straight to our website where you can learn more. Once again, thank you all so much for joining, and have a great rest of your week.
Thanks, Chappie. Thanks, everyone.
All right.
everyone.
Thanks,
Thank
everybody.
you. Cheers.
Nice background. This is going pretty well.